Another fun way that we can use proportions is identifying things called similar triangles. And I use these all the time. Similar triangles help me determine unique pieces of information, like how tall is a tree that I can't actually climb and measure. Or the example I'm going to look at right here is, I'm walking along and I see a lamppost. I'm curious, how tall is that lamppost? Well, I can't climb it. My tape measure doesn't go that high or that far, so what can I do? Well, if I understand a little bit about similar triangles, I can determine what the height of this lamp is. And how I'm going to do this, let's say for example, I'm going to use myself, and I'm 6 foot tall. And I'm going to stand in line with that, so I'm going to stand right there. That's me. I'm 6 foot tall. So I know that in line with where I'm looking at and that lamp, and I can determine some distances here. I'm walking along, I can find out this distance is there. I mean, it's a short distance. Let's say it's about 4 feet. And the distance from the lamp post to where I'm standing is about 10 feet. And you guys can see that this all makes sense. These are all measurements that you can do or you can measure without having to climb a pole. Well, when you're doing that, what I was able to do was create two triangles. So imagine I had this little triangle right here where I'm 6 foot, and the distance from the point of the triangle to where I'm standing is 4 foot. Then let's look at this larger triangle that includes a lamppost. And some of the information on that lamppost, well, I don't know how tall it is, but the distance from the lamppost to the end of that triangle is 14 feet. So I'm starting to get some information here about two different triangles. The relationship of this triangle with the bigger triangle are similar, which means that its corresponding sides are also similar. So I can take, for example, the height of the lamppost, x, relate it to my height, and that's going to equal the distance from the lamppost to this point, which is 14 feet, and the distance from me to this little point, which is 4. And there I have a proportion. And with that proportion, like all other portions, we can solve that. I'm going to multiply both sides by 6. I'm going to kind of reduce that down because I'm kind of getting some big numbers there that I don't know what to deal with. 4 goes into 14 7 times. Well, I'm sorry, 14 goes into 4. If I factor a 2 out, both of them, well, I'm left with a 7. I can also factor another 2 out over here into that 3, into that 6. So that equals 7 times 3 equals 21. So I was able to determine what x is. X equals 21. But what did it represent? Well, at the time it represented the height of that lamp. And that lamp is 21 feet. So I was able to do that without actually having to climb the lamppost. Just looking at some similar triangles and discovering where they're at. And we can do that with trees, we can do that with lighthouses or buildings, in lots of different ways.